Mute. Okay, let me check my audio. Is it hearing me? It's hearing me. Okay, good. So, okay, there comes some people. All right, so this cybersecurity apprenticeship program is going to start next semester, and there will be 2 cohorts, 25 people next semester and 25 people a semester after, that get placed at paid jobs. It'll pay something. Apparently, at one point, they thought it would be $35 an hour, and then they thought it would be $20 an hour, and nobody really knows. But anyway, they'll pay you something. And you have to take certain classes to get ready, and there are other requirements. So I recommend going to this event on Tuesday. I told my whole Tuesday night class to go there, and you people might want to go too. I asked them if I could record and live stream that event, and they said, oh, probably not, because some of the bean counters got involved, which is a shame. Anyway, so you may have to actually show up in person if you want to learn that stuff. All right. Anyway, that may be of interest to a lot of you. It sounds like a pretty good track to get to a job in security. Are there any questions about anything? Yeah.
So this slide last year, the first meeting is the same about the 30, about the next week.
The last meeting.
Apprenticeship, security.
Yeah, I don't know.
Is it the same topic, same material?
I don't know.
Okay.
I'm not in charge of it. Sorry. Yeah, there was a meeting last. I assume it'll be mostly the same. This last one, but I don't really know. It's a good question. I'm not in charge. It's Steve Nelson's the main guy in charge, although I'm somewhat involved. Certainly, I recommend it. But there are administrators here in the loop, and that's why you start having trouble getting intelligent answers to questions like, can we record it? Because you know, it's hard to understand at college, but the thing to understand about government people is they are risk averse. The only thing they're comfortable doing is everything exactly the way it was done before by somebody else. Anything new, they're afraid of. So private companies are the opposite. They encourage risk taking. They want you to be the new hot thing to sell things, but in government, they avoid risk. It's a whole different way of thinking. Anyway. All right, so we didn't actually do the first chapter last time, although it's all right because there's not much in it, but I wanted to make sure and touch on it this time. So this is the introduction to the field that you're learning about here. Ethical hacking is kind of a euphemism, right? Hacking is a crime on the US statutes, and yet, so for a long time, until maybe 8 years ago, it was considered immoral and perhaps illegal to teach hacking at school. So we tried having professional defenders who didn't know anything about combat. This will work about as well as having soldiers that don't practice fighting. It didn't work very well, and it led to this crazy world we're in, where everything is extremely insecure and everybody's getting hacked right and left. So we changed our mind about that, and now we teach attack skills at college, and we have to somehow say that we are teaching people to attack servers, but they are not criminals doing bad things. So the current euphemism for that is ethical hacking. So an ethical hacker attacks test systems that are up there so you can attack them, people that have given permission because they've hired you for a penetration test or it's some kind of contest or something. They don't hack random people on the internet that didn't give permission, because that would be a crime. Then you'd be the other kind of hacker, and it would generally inhibit your ability to succeed as a professional. So a penetration test is when you break into your system.
It's really nice. Notice we can
say how they got in and what recommendations they have for how you should improve your security. And we're in the, I see Kaz there, he's on our team, going to CPTC.
Okay.
We went to Rochester. We were one of the nationals competing at pen testing, and that was it. You had a day to hack into a bunch of servers at an election-based company, and then you had to present a report to the management of all the things you found. And they want you to explain to them in non-technical terms to management what you found, what their problems are, and what they should do about it. So you have to be not only able to do technical things and find technical weaknesses, you have to be able to present things to non-technical managers, and that is the whole thing of business we were talking about before class started here. There was a time, maybe 15 years ago, when people with technical skills were so hard to find that companies would put up with hiring people with ridiculous social and personal and psychological defects to get experts. I remember when I worked at UC Berkeley in the research lab, there was a guy who was an expert at computer graphics, and you could smell him all over the floor. He never took a bath, and nobody would say anything. And the original hackers at MIT were all like this. They're people who were very, very unable to do even the most basic social interaction, but they were good with computers. That time is over. Now companies don't have to put up with that anymore. They expect you to know technical skills and also to be able to talk to people and take orders and show up at a meeting on time and wear clothes that aren't too horrible and be respectful to your boss and all those soft skills that technical people have traditionally felt like they're too good. They can't bother me with being nice to the boss. I'm smarter than the boss. I will have contempt for the boss. And that doesn't really fly that well in the private sector anymore. In the public sector, it seems to be a requirement. But anyway, one time they called the crackers the bad people and the hackers were the good people, and people really cared about these words. It's not very important. Their script kiddies are one of the lowest category of attackers. One thing you have to do is threat modeling. Like people say, I want my servers 100% safe. I say, well, you can't have it. You can't have 100% uptime. You can't have 100% safe. You can't have 100% security where only the good guys are getting in. That nobody on earth can have that. People shoot the president. People hack the NSA. No amount of money can get you 100%. So we have to get realistic. What is the real threat, and how much of that are you going to put up with? And so the lowest level attackers are the script kiddies. These are people that just download something like the low orbit ion cannon and run it and don't even really understand how it works. And so you should be able to have defenses against that. And that is one thing. If your company is just irritating, is doing something unfashionable, like you're an oil company and it's currently fashionable for the activist types to say we should end oil companies, then you can expect attacks from a bunch of unskilled attackers that are not really, because you're just generally seen as unpopular. Anyway, so beginners will just use code without understanding it. More experienced penetration testers will learn how to write their own code. In this class, you're taking the first step of being towards a professional penetration tester. So what we're going to do is learn how to use some of the code that is already in Kali Linux. Kali Linux is the American standard for penetration testers. That's what people typically use for almost everything technical, because everything you need is in there. If you can move beyond that and start writing your own attacks, and we do that in the 124 class, the advanced hacking, which is not that hard either, but it's a step beyond using existing tools. So like I say, you'll hopefully move a bit above a script kiddie here to where you can use tools that somebody else wrote and understand what they do, which is what most computer operators do. They mostly use something like Microsoft Word, and they don't write it, they use it. And that's where we're going to be. You're going to use tools like Nmap and Metasploit that are there for you. All right. None of this stuff really matters. There are certifications out there to get. Security Plus is probably the first step. At this college, we start with A+, Net Plus, and Security Plus. We call that the core, and that's the idea. This is considered pretty much the basics that any computer professional should know this much. You should know basically how hardware works, basically how networks work, and basics about security. Then you can specialize in something, web design, supercomputing, protecting security, offensive hacking, Cisco routing, something like that. Microsoft domains and server administration. Those are all really good things, but you should know at least this much just to get started. Certified Ethical Hacker is probably the certification most closely tied to this course. This course plus 124 approximately prepares you for this test. It is not tied to the test. I don't use their materials because this certification has a very bad industry reputation. I passed the test. It's okay, but it doesn't make you a pen tester. Real pen testers laugh at CEHs. I don't think it's really marketed as something to make you a pen tester. It's marketed as something to make you a more clever system admin, more aware of security. But it's very limited. The certification that is really respected by pen testers is OSCP, which this is it. This is the one. I have a couple students that have this, but none of the students graduating from our program have gotten this yet. They're trying. Probably within about 6 months, several of our most advanced students will get this certification. This is what real pen testers have. This is analogous to the Red Hat Linux certification, which is the best Linux certification to get, because they both have the same property. It is not a multiple choice test. To get this certificate, you train, and then they connect you to a network of computers. There's like 8 computers there, and you have to hack into like 5 of them in 24 hours. That's the test. And then you have to give a report explaining what you did to get in. And that's I think you have 48 hours total or something like that, and that's how it goes. So it's not multiple choice, it's proving you can really do it. And the same thing's true of the Red Hat certification, by the way. You have to have a real server, and you have to really make it do stuff within a limited period of time. That's actually, if somebody has that, you know you can hire them at your company, put them on the server, and they won't be a blithering idiot. Whereas a multiple choice test does not have that property. A bunch of people just cheat on the test, and they have no idea how to really do anything. So CISSP is a non-technical certification, and almost everybody in security has to have it, which annoys the hands-on pen testers. But this is like your license or your union card. This is considered to be tested. It means we can trust you with information. It is a management certificate. It is not hands-on technical. It is knowing all the terms. So there are two categories of people that do it. One is there are technical people who get this certificate, and they have to learn some management. And the other is there's MBAs who get this certificate, and they fear it greatly because they have to learn A+, Net+, and Security+, which is a lot of stuff to learn. Whereas us, we already know A+, Net+, and Security+. If you don't, you can certainly take classes here. And then all you have to learn is a little management. So it's much more achievable from this side than from the other side. But it's very good for both sides to do it because then they can communicate. The big problem in our business is the technical people tend to be rebellious, undisciplined, immature, and sort of generally unstable emotionally and crazy. And the managers do not know how to keep them in line, and they can't communicate with each other. All the managers know is my hacker, my security guy is always yelling about something. It doesn't make any sense. No matter what I do, he stays mad. And can we just fire him and hire somebody I can talk to? They keep telling me we need this guy, everything will fail without him, but I'm worried about this guy. He's like kind of nuts. And you've got to learn how to communicate with management and how to respect management, or you will never succeed. And that's what this kind of certificate is supposed to do. Yeah. Any comments? Okay. Anyway, SENS has a lot of really good classes. They're just really expensive, like $3,000 or $5,000 for a class. But once you have a job and your company's paying for it, these are great classes to get. And our security program here, I have made it by imitating SENS classes, really. Most other colleges follow the NSA model. The NSA has a model for cybersecurity education, which they call cyber assurance and cybersecurity. And it consists of following a bunch of specifications that were defined in 1994 and never updated. So I was not very happy with it, and I completely ignored it. And I follow SANS. And that seems to be closer to what industry really wants. This is what real security professionals, they go to a conference, their boss pays $5,000 like at Black Hat, they take a SANS course in mobile forensics or something, and then they're ready to do it on the job. So we have about 10 hacking and security classes here, and they're all pretty much copies of SANS classes. To just be a cheaper version of SANS class, that is my goal. Anyway, all right. So you can, to really be safe legally, you should only be using test systems that you set up or that you have permission to hack into. If you're doing anything to somebody else's system at all, you're running some degree of legal risk. This means that all security research involving how many systems are insecure, how fast is this virus spreading or anything, is all somewhat illegal. And the government knows that, and a lot of people do research. I've done quite a bit of it, but I try to make sure not to assign anything illegal for homework. Although occasionally I've discovered that some of my homework was illegal and had to take it down. Lockpicking, for example, is not illegal. I was worried about it for a while. Anyway, so if you have to take your own estimate of how much risk you can take. I'm not aware of anybody who is a student in my class or anything comparable that actually did reasonable things and got punished for it. It's really hard to get punished. You have to really do something awful like start Silk Road or something. As far as I know, none of my students have ever started doing bad things and gotten in trouble. If so, people would have shut me down. There was a big concern about that when I started doing this about 8 or 9 years ago. The students will commit crimes, hack the college, we'll all be in disgrace. So don't hack somebody, don't do anything illegal, but as far as I can tell, there's no problem. People that want to do that don't go to school and take tests and buy textbooks and all that. They're on a different track. All right, there is always some pressure to outlaw hacking tools. Sometimes even possessions of things like Kali Linux is considered a crime. Possession of Locksmiths is considered a crime. They did that in Germany. They did it in France. It has not yet happened in America. Texas did it briefly. At one point about 10 years ago, Texas passed a law that we don't want people destroying evidence on computers. So every single person who ever works on a computer has to be a PI. But to get a PI license, private investigator license in Texas, you had to have like 8 years of law enforcement experience. So the only people that could get it were ex-military and ex-cops. So every geek at Best Buy now had to be a cop. And when they they rapidly repealed the law. They say, that's not really what we meant. And on it goes. The governments are struggling to handle this cyber thing. Like I mentioned before, governments are very slow to innovate. The whole thing about government is not to take a risk and not to change anything. And so the speed of Silicon Valley and computers is just really hard for them to cope with. Their laws are always about as out of date as the 10 Commandments, trying to figure out how to apply those laws to the reality of the modern internet. Like, people get on the internet, make a fake ID, harass some teenager until she commits suicide. And then they say, did you commit a crime here? And if so, what crime? Is that murder? Is that stalking? Is that free speech? What is that? And it's not easy to tell. Anyway, right, so port scanning is legal. Even without permission, as far as anybody could tell, nobody's ever been hurt for it, prosecuted for it. Everybody has computer usage policies. City College does. These things usually say we don't let you do illegal things on our network. If you start downloading pirated MP3s on our network, we don't approve of that. We will suspend your privileges if we catch you. City College now blocks BitTorrent with a layer 7 firewall, so it's very hard to steal music on campus because people totally would do it. And it does make a problem for the college, so we try to prevent it like every other company. Not like we really care about protecting the music, but we care about not having all the legal trouble that comes from letting people do that. All right. There's a lot of laws out there. They are pretty messed up. The laws are far behind, and they're written in a way that makes it really hard to understand what's legal and what's not legal. There's a computer hacking statutes. The main one that hackers come in is the Computer Fraud and Abuse Act. This is the one I was accused of violating. I was doing something I thought was fine, and my lawyer said, well, I could make a CFAA violation out of that. CFAA is written, if you connect to a protected computer and you do anything that you're not authorized to do, you've now broken the law. That's how most of these laws are written, which means that the company actually defines what the law is by defining what their authorization is. However, people that put up websites typically do not have any page saying what you can do with the website. So what it really means is if you connect to anybody's server and you do anything that they don't like, you broke the law. And that, however, you probably can't be prosecuted unless you do something that they can easily convince the jury was wrong, like you stole a bunch of credit card numbers and then bought something with them. Now that would be pretty easy to convince them you did something wrong. But if you connected and downloaded a couple of things to prove that they had a vulnerability and then told them, then you would have an argument that you really hadn't done much harm, and they would say you might have technically trespassed on the law a little, but you really didn't do any harm, and now it's going to depend on whether you get a good lawyer and you cooperate with your lawyer and try to avoid being an idiot in court or not. So, it's very unclear. And there are some famous egregious cases, like Aaron Swartz was a young guy at MIT, and he was mad at Elsevier. Everybody in the scientific world is mad at Elsevier. Elsevier is a Dutch company, and they are just exploiting the scientific community shamelessly. They have been for 100 years. If you do any kind of research, you have to pay them $10,000 to subscribe to a journal, and then you have to pay them $100 per page to publish in a journal, and then they lock it up so nobody can see it without paying these exorbitant fees. So normal people cannot read any of the scientific research, which is in fact funded at public institutions by their tax money. So a lot of people think this is terrible, and so Aaron Swartz programmed a laptop to download all these copyrighted things at MIT and just put them on BitTorrent so everybody could get them. And so he was technically guilty of thousands of violations of copyright law, and they came at him and said they were going to lock him up for 30 years. And I kind of fault his defense attorney, in my opinion, because he freaked out and killed himself because he was afraid he was really going to go to jail for 30 years. But you have to understand, this happens all the time. They say you're going to jail for 30 years. It's a bargaining position. Now you bargain, and if you have some kind of argument, you can probably get a 5-6 month suspended sentence in the justice series. But he didn't stick around for that. He killed himself. It's a shame. Anyway, so that's one law that all the hackers pretty much run afoul of the CFAA sooner or later. The Electronic Privacy Act is another one, and the Stored Wires Act is another one that protects the devices themselves. There's a lot of others, and now there are regulated industries like HIPAA and PCI that regulate certain industries. HIPAA regulates medical industries, and PCI DSS is not a law, it's an industry self-regulation that regulates people that take credit card payments. But they all have rules you have to obey or you will be punished to some extent. Certainly spreading viruses is illegal. Defeating login systems, getting on someone else's system and running code is certainly illegal. Stealing private data is illegal. But it's very hard to prosecute these things. So if you do a pen test, you have to get a contract first. Just like if a contractor comes to like rebuild your roof, they get a contract first because something could go wrong. It could end up costing more money. Somebody could get injured on the job. And then you're going to wish you had clear contracts so you knew whose fault it was and how much money people owed. And if you're doing a penetration test, you might interrupt a business, trace data, cause disruption, cause them to lose money. And then you will wish you had a clear contract that made it clear who's going to pay how much and whose fault it is. So that's the game. The main thing, to be a pen tester, you have to be very good at technology, and you have to be able to communicate with IT and management. These are typically not the same people. Typically, pen testing is done in teams. They have junior people that are just being trained up. They have experienced pen testers that are good at scripting and hacking into things, and they have one management type wearing a suit who can go present it all in the right language to management. It's usually not one person doing all these things, but it could be. All right. And you saw last time Duffy demonstrated this project where you take over a machine with Armitage. Let me take a look and see if people have been turning that one in. I think I might do the project X0 here. Let me, but your scores. Oh, that's right. I'm not publishing scores up there. I can't see. Okay. So I can't, how many people have done project 0? Project 1 and 2, nobody's done them either. Well, some of you have done that. All right. Let me point to some of these projects then. Projects are not due for a couple of weeks, but you should start. Let me go down here. Oh, I didn't put the project 0 in this class. Never mind. We'll start with project 1. So project 1 is getting your Corley virtual machine up. That's all it is. And project 2 is just getting your Windows machine up. So these are step-by-step things, and there's no real hacking in these. This is your attacker, Kali Linux, and this is your target, Windows. So all you have to do to make a Kali machine is just go download it. If you go online to offensivesecurity.com, you download a virtual machine. The 32-bit version I recommend. It's better for some projects. Most projects are fine on both, but 32 is better for some things. And then you just open it or import it into your machine and run it, and then you will have Kali. Now, the latest version of Kali is quite a bit less friendly because VMware tools don't seem to work. But you can still use it for these projects pretty easily where you're going to be using the graphical interface. Later on, I'll show you how to connect with SSH. So you log in with root, and the password is Tor, root backwards. You can change it, but it's fine to leave it alone as long as you keep it on a private network so other people can't get at it. And we're not going to be handling any real sensitive data here. So the desktop you get looks sort of like a Windows desktop. You can run this Firefox to browse the internet. Most of the time you do everything from the command line, which is the reason why Linux never got popular on a desktop. You can use the mouse and almost never works. Like even if you download a file and double click on it to install it, it won't work. It's ridiculous. This is why there's Linux advocates that think we should all use Linux because it's free, but nobody does use Linux because it's hard to use, except for professionals. And we're becoming the security professionals, and you have to get used to using this command line. Many people are unfamiliar with the command line and confused by it. So if you have not learned the basics of command line, I did put a project here, which I think I made extra credit, a basic Linux. Maybe I'll have to add it back in. Looks like I don't have it on my latest 123 page. I will add it back in as like X0. So you can learn the basics of command line, but you don't need it until a little later. Let me just check. Maybe I put it in as project 3 or something. I rearranged my project a little bit for this semester. Yeah, it's down here. Okay, it's down here at project 7. So we'll get there. I thought I put it in here where you just learn the basics of the command line, but you won't need it for a few projects here. So for this one, Duffy demonstrated it at the club last week, or Stewart. You just use Armitage and take over a Windows machine. So the first 3 projects are what he demonstrated. Yes? It is here. It's down. I put it down here as 7, I think. So I thought I kept it. There it is. So maybe I will show it now. For people who don't know any command line, here's how it works. So you open a terminal here, and you can make the font bigger with Shift-Control+. You may not need to on your machine, but I need to when demonstrating it. All right, and so here's a few basic command lines. LS is your most common command. The fundamental problem with the command line is you can't see what's going on the way you do with the mouse. So ls shows you what's in your current directory, which normally you can just see in the folder structure. So I'm in my home directory. If you want to know where you are, it is pwd to print working directory. And this is the hard part of a command line. In a command line, you are in a certain location and you can't tell. You have to get used to the fact that you're in a folder and you move somewhere else. My generation learned this from a game called Zork, where you have to go north, north, west, west, and remember where you are. And people that have never used the command line have not learned this skill. You have to remember where you are. When you start the thing, you're at your home directory. And on Corley, your home directory is /root, and you're always running as root. Most Linux, it's somewhere else, but that's where it is in Corley. So you can move with CD. If I move, I can move to a directory like /. / is the root of the entire system. And if I do an ls here, I see certain standard Linux things like etc and var and user and sbin. Those are more components of Linux. And if I do ls space -l, this gives me a long list that shows me more information about things like whether they're a directory or a file. D means directory, and dash means file, and how big they are and when they were last modified, and so on. There's a few other things here. Help. There are two kinds of help in Linux. The one that they always tell you about is the manual, man ls. This is useless. It is 25 pages long of every possible technical detail. Good luck. Especially for beginners, this is nowhere. The far more handy help, which only works in some versions of Linux, but it works in Corley, is --help. --help will show you a short page that would fit on even one screen usually, that gives you the most common options. And so here you can do an ls, and one thing you can do is an ls -l, which it would probably tell me about if I could only figure out how to scroll back a little bit. By the way, to fix this problem, when you can't see what you're doing and it scrolls off the screen, you use pipe more. And that works in Linux and Windows. Here's another problem that comes entirely from using a command line, which GUI people don't have. My ls-help was going off the screen. So you use pipe, which is shift / and pipe it through more. And now it will show me one screen and then stop, and it won't show me any more until I press a space bar. So now I can see I've got A, B, C, and D options. When I press space bar, I see some more. And down here on the third page is the -l. It tells me use a long listing format. So even the short help is pretty long and annoying, but that's the way it is. You get out of this with Q. And by the way, whenever you're stuck in something you don't like, you hit Control-C. Control-C will cancel whatever's going on and let you out. And if you're a virtual machine, you can always just close it and reboot it if you're lost somewhere and you can't figure out how to get back to a normal place. So, all right. And by the way, the other thing worth mentioning is every time you're stuck, your most useful help resource is Google. Just Google, how do I do something on Linux? And there'll be 100 blogs showing you how to do it. Anyway, so to edit a file, we're typically using Nano. It's good. Nano is hard to use. It's very old. It is good to learn because this is how you control a file system when you have no mouse and no graphics. And even though you do have some ability to use the mouse and graphics on your Corley machine, when you take over other machines, over a network, which is where we're headed, you will often have only a command line and no ability to do graphics. So you should know how to do things with no command line, with no graphics. So if I move into my home directory again and then do ls, here's some things here. I'm going to make a directory. mkdir will make a directory called 123. And let me see if I can make this stuff higher because the projector in this room is low. All right. That should do it. All right. And now I'm going to make a file with Nano. Nano, and the file name is foo. And in here I can say hello, more stuff, get more stuff, type whatever you want, and you save it with Control-X. This line at the bottom is your help message. Control-X is exit. The caret means control. Everything is capital letters because this dates from the 1970s when computers only had capital letters. So Control-X, you can type a lowercase letter, but it will interpret it the same. And then Y will save the buffer, and then Enter will write the file. And you will see this in every project. Edit the thing with nano, Control X, Y, enter to save it. Now, if I do ls space -l, I now have a file called foo. And the file is 34 bytes long, and it's here. Now, I meant to put that file in the 123 directory, so I might as well fix that now. I'll move it with mv. I move foo to 123. And here comes a chat message from someone remote. Let's see if I can figure out what that is. Can we use V or, yes, oh yeah, I'm glad you asked. If you know Linux and you want to use VI, go ahead and use it. I don't teach it, but you can use it. Very good question. Expert people use this thing called VI, which is fast once you know it and just baffling and frustrating if you don't know it. And it's sweet. By the way, here's another fun fact. If you don't even want to use nano, there's a graphical editor called LeafPad available. If I wanted to modify this file, I moved it into the 123 folder. So I can move into the 123 folder with CD, and then I do an ls -l. And here's my file called foo. If I want to edit it graphically, I do LeafPad foo. And this is like Notepad. You save things with file save, and you can use the mouse and all that jazz. So you could make it easy on yourself this way, but I recommend getting used to nano for when you are controlling another person's machine and this is all you have. But if you get fed up with that nonsense, Corley does have a graphical editor for WIMPs. Anyway, in general, this is the Linux ethic. It is considered tasteless and inferior to use the mouse on Linux. That's why they never fixed the GUI. And by the way, it's also considered tasteless and lame to use nano. Pros use VI. So I've gotten over caring, but in fact, I'm teaching you stuff. Some people will say this is horrible. I shouldn't even be teaching nano because it's too easy. You should use VI because suffering will impress everyone. I'm not too much in that field, although I was brain cured and I somehow got a little past it. Anyway, so, all right. So you can create a file, you can change directories, and you can make a directory. You've seen all that. The other thing I wanted to show you is output redirection. That's about it for basics. If you type date, this prints out the date and time on the screen. Now you can take whatever was going to go to the screen and put it in a file. I can put greater than foo, and that will take what was going to go to the screen and put it in foo. But it's going to erase everything that was in foo. If I nano foo, the old stuff is gone, and all I have is the date. So that's, if I want to add something, I can do echo, hello. That will just print hello on the screen, which is kind of stupid, but I can add it to a file called foo. Now, if I do it this way, it's going to erase the date. Now, if I nano foo, it's hello and the date is gone. If I want to have both of them in a file, I use two greater thans. That will add it to the end of foo without erasing it first. And now when I nano foo, I've got this line and that line. So you can build a file line by line without a text editor, and you often have to do this. For example, if you have a command like that man ls that made a long response that was too long, one way to handle it is to put it in a file. And then you can edit the file. You can even download the file to a more comfortable environment like Windows and open it in something you like Word or Notepad, and play with it there. And that's often what you do. Get off this system to a more comfortable system for fancy things, like searching through it. And all right. And there's a little bit here about shell scripting that you'll get to, but I'm not going to worry about that right now. All right. Are there any questions about any of this? Then I want to move on and talk about Chapter 2. You should start doing your projects, but you have a couple weeks for that. And I'm planning to do at least part of Chapter 2 today. All right, so let's get rid of this one and go on to this one, and then we'll have some of those Kahoot contests. We should be able to get down to at least the first Kahoots. So this is the review of Net Plus. You've hopefully already had this in an earlier class. If you skip that class, then this is where you can decide whether you want to keep going in this class or you want to go back and take an earlier class. This is how the network works. TCP/IP is the main thing, and a little bit about binary and hexadecimal and such. Computers originally were mainframes, and every computer had its own language, and it come with a stack of manuals like a phone book. And if you knew how to run an AMDAL, it was totally different than running an IBM or VAX or all the other computers. And eventually they decided this is for the birds, and they ought to all speak a unified language that can talk to each other and create something called the internet. And that language was Unix. The protocol that the operating system was Unix and the language it was written in was C. They were embedded together to go together, and now all you had to do was write a C compiler for every machine, and then you could compile Unix and talk Unix, and now they could talk to each other because they're all talking the same language. And to send data over the network, you have a protocol. Protocol is just like a diplomatic protocol. If you talk to somebody, you say hello, they present you with papers, you look at the papers, you exchange a gift, you know, there are rules. And when you call on someone on the telephone, it rings, then they pick it up, you say hello, they say hello, and you don't transmit your message until you've gone through that handshake. And networking protocols work the same way for the same reason. So TCP/IP is the protocol used to run the internet, and it has 4 layers in the TCP/IP stack. There's another European model called the OSA model with 7 layers, but we're not using that in this lecture, although you will get that if you go through the Net Plus class. So the application layer is the only layer most people ever know about, where you see something a human can read, like an email or a web page or a video or something, and you click on a link and it goes somewhere else. When you click on a link, it has to go through all these other layers to send the data out the card over the internet, but you don't know about that unless you're an engineer. You just use it at layer 7, or layer, the top layer, application layer. This is where human readable stuff is. The transport layer is where data is broken up into chunks that can be passed. You cannot move large amounts of data over a network. You have to break it up into chunks. Unfortunately, the chunk size is about 1,500 bytes in modern networks, which is ridiculous. If you watch a Netflix movie, it's gigabytes of traffic. So millions of packets are going to you one at a time and being reassembled for no good reason at all. It's doing that because the network protocols were designed decades ago when networks were 1,000,000 times slower and in many ways never updated, but that's the way it is. So it breaks it up into a lot of little chunks at the transport layer and addresses every little chunk. Then it goes down to the internet layer, which routes it across the internet to find the physical location of the target machine. And then it goes down to the network layer, which is what moves it around on your local network. After it's addressed, it has to find the device on your local network that leads out to the internet, like your home router. So, all right, that's the application layer. Here's familiar protocols like HTTP for web surfing and IRC and Telnet for some people who use command line clients. These all present information in a readable form to the end user. And so here they are, HTTP for the web, SMTP for email, SNMP to control network devices like firewalls, routers, and switches, SSH to control command line servers at a distance like Amazon Web Servers. Telnet, unfortunately, is the very old protocol to control servers that does not have any encryption, so everybody can steal and modify your data, including your password. So it is a terrible protocol, and nobody should ever use it, and a ton of people continue to use it even though it's dangerous. But they should be using SSH instead. So the transport layer breaks your data into segments ready to transport, and it uses typically TCP or UDP. There are some other protocols here, like general router encapsulation, but they're not used as commonly. TCP is the most popular protocol by far. 99% of all the data on the internet is going by TCP because TCP delivers data with confidence, so you know it got there. It is rare that you are sending something and you don't really care whether it gets there. So TCP has a handshake. You send a SYN to a server. If you want to see a web page, first you send a SYN, it sends a SYN ACK, and then you send an ACK. That's a handshake like ringing the phone. Then you don't send any data or receive any data until that is done, because that verifies that somebody is listening and they're ready to receive data. The header is this. These are bytes. There's 32 bits across. So each one of these is 4 bytes across, and there's several rows of it. This is the raw protocol. Everything on the internet is defined by these things called RFCs, which are called requests for comment. These are the official specifications for the internet, and all the web browsers and routers and switches and servers have to pretty much follow these rules, or their network traffic will not be accepted. So the source port and destination port are 16 bits each. Those specify which process on that server you're trying to talk to. The sequence and acknowledgement number are used to reassemble data from all these little packets to build something bigger like a video. The flags are here, like SYN and ACK. They're single bits. Those are used to specify the purpose of the packet, and that's how you do the handshake. You send a packet with a 1 in the SYN bit You get a packet with a 1 in the SYN and a 1 in the ACK, and then you send a packet with 1 in the ACK. That's the three-way handshake that prepares a TCP connection. And the rest of this stuff is not too important right now for us, although it'll be useful occasionally later with advanced attacks. So the critical stuff for us is the source and destination port and the flags like SYN and ACK. There was an old attack mentioned in your book where you guessed sequence numbers, but that hasn't worked since the 90s, and I'm not going to worry about it too much. So there's a variety of these things. Synchronize and acknowledgement are the main flags. There's a few others that are fun, like if you finish a transmission and you're done, you send a FIN to terminate the transmission. But if you just want to cancel it halfway through because like the browser closed, the user closed the window, you send a reset. So company firewalls that want to block things like Facebook and the Great Firewall of China that wants to block things like Google typically send a reset on your behalf. Oh no, they decided not to look at that page, never mind. So if you block resets, you can serve pages right through the Great Firewall of China. And you'll be doing that in a class. The part of blocking resets, not intentionally serving them with the Great Firewall of China, although you could do that, and it probably wouldn't hurt you any, but it might get someone in China in trouble. So there are a whole bunch of people that do, in fact, maintain forbidden technology and serve it up in ways so people can see it in China because they want to help political causes in China. But you're not doing that as part of the official homework in this class. Anyway, additional sequence number is a 32-bit number to start the connection. Very early machines before the 90s used to just start with 0 and start the next one with 1 or something. And it turned out that you could guess the sequence number for somebody else's connection and just take over their connection. This is one technique Kevin Mitnick, one of the most famous hackers in the world, used to take over servers. He would just load a web page, look at the sequence number, then call the administrator on the phone, I just hacked your web page. The server administrator will now log in, and he can predict their sequence number because it's going to be one after his. So he lets them log in and then takes over the session by sending in packets. Here's another fun fact about networks. You break everything up into these little packets and you send them. Very often packets fail and get retransmitted. So it is very common that you actually end up getting 2 copies of the same packet. So all your network devices just notice this. If they get 2 copies of the same packet, they just throw away the second one without acknowledging it or telling anybody. So if I send a fake packet with the right sequence number, it'll assume it was your packet. And when the real packet comes, it'll just throw it away. So I can wait till you log in, take over your session, and now I'm the administrator, even though I don't have your password. This exact attack doesn't work very much anymore because the sequence numbers are unpredictable. But a modern version of it works, and you'll be doing it in the project. If you just steal somebody's cookie off a website, you can put it in your request and be them. And this will get you into almost every website on the web. All right, it amounts to the same thing. TCP ports are just part of an address. They're like an apartment number. You're in the right device, like being on the right building, and the port says which person at this building do you want to talk to. So there are 16 bits. There are 65,536 possible port numbers. Every packet has a source port and a destination port. You can block ports with a firewall. You set your operating system to refuse to take packets coming in on certain ports, and you should. Every server should have every port blocked except what you're really using, because hackers can take over your machine and start extra services that you didn't want them starting. And if they listen on other ports, you don't want to let that traffic through. So it is basic hygiene on your network to not allow any traffic on the ports that you do not want people using. But amateurs and other people can make mistakes, and so you can sometimes launch services and listen on funny numbered ports, and it will get through. The first 1,023 ports are called well-known ports. That doesn't particularly mean they're famous. It's just a technical term. It means they are reserved for a certain purpose, and it is considered improper to have anything else using those port numbers. If you write a game or something, you can use any port you want above 1023, but you shouldn't use anything below them. They're all reserved for famous services a lot of people use, like email and web traffic and things like that. Ports you should know, the most common dozen or 2 dozen ports. Every CompTIA exam expects you to know them. FTP uses port 20 and 21. You'll be hacking into FTP servers in quite a few of the projects. FTP does require you to use a name and password if you choose to turn that feature on, but it transmits the password with no encryption over the internet. So this is a terrible protocol that everybody should have abandoned 30 years ago. Just like Telnet, This is called anti-security. I'm not sure that's a technical term, but it should be. There are a lot of security measures that do more harm than good. And putting an FTP password on things is the opposite of security. It harasses your users because they will forget their password, and it doesn't stop the bad guys at all. There's a lot of poorly thought out security measures that are the opposite of what they should be. What you want to do is not irritate the good users and make it hard for the hackers to get in. And encryption does that. But FTP passwords don't. So if you connect to an FTP server, a box will pop up asking for your name and password. And until the very latest browser versions that came out this year, browser versions, it won't tell you that it's going to send this with no encryption over the internet. So users don't know this. The very latest versions of Firefox, anyway, will actually warn you now, which is a huge leap forward when you try to log in and there's no encryption. That's been 30 years overdue coming. Port 25 is used to send email. Port 53 is used to resolve domain names like cisco.com to an IP address, which is necessary to do all network connections. Port 69 is trivial file transfer protocol. This lets you move a file from one machine to another, and there is no authentication at all. It's not possible. This is used by IP phones and routers to update their firmware. So it means also you can take over these devices by just running a malicious TFTP server on the network and triggering something like a reboot. So you reprogram their phones to do something else. This and FTP and Telnet were all protocols designed long ago before the internet existed, when the only connection was from your little terminal to a machine through a cable in your room. That's why they were designed with no security. Then they were just put on the internet without the redesign, even though their security properties are horrible, and they never had any business on the internet. Because for decades, so few people understood the internet that you could get away with doing just blindingly stupid, insecure things on the internet and feel safe enough because very few people understood it well enough to realize how easy it would be to just take over your stuff. And that led to the wave of hackers finding out, hey, man, you could just learn a cute trick in half an hour and take over stuff. And you totally could. And you still can pretty often. Port 80 is used to surf the web, although not very much anymore. Almost everybody has now moved up to HTTPS, thanks to Edward Snowden. Edward Snowden dumped the military documents and showed that the NSA has been treating American companies as adversaries and hacking them like crazy. And that made everybody so annoyed, they all started encrypting a lot more of their data, so it led to a great security improvement. Although, if you think you are doing something on your computer that stops the NSA, you are a fool. And you're not going to stop the NSA with anything you can buy. I recommend not trying to hide something from the NSA. You're not going to win. However, it did motivate a lot of people to encrypt stuff, and it'll stop a lot of people, like most of the criminals. So it's a good thing to encrypt more of your stuff. 110 is used to retrieve email in old-fashioned systems. Port 119 is used for NNTP for news transmissions on very old systems, not used much anymore. 135 and 139 are Microsoft ports used for file sharing and Active Directory logins and a lot of other Microsoft things. They are extremely insecure and should not be let out through your campus firewall. They're necessary inside your network and Microsoft networks. 139, 135, and 445 are the source of almost all the spreading viruses on the internet. There's a series of flaws, one after another, in those services. 143 is another email protocol. So let me make a couple connections and show you a socket. This is a Mac, and a Mac is a, let's get rid of this. A Mac is a Unix machine, which is very close to Linux, and therefore very nice to use, because this is using the original software that ran the internet. Microsoft is imitating it with their Windows product. So if I do netstat, and it's AN, pipe more, this shows me the status of my network and all the network connections. And you'll see my machine has a connection to port 443, a lot of connections to port 443. Those are my web browsing sessions. I've got a browser someplace with some pages open, and it's connecting here with port 443. If I go to, say, one of my unencrypted pages, here's one of my deliberately vulnerable pages for people to hack into. This is actually not HTTPS, which is not that common anymore. So now, if I refresh that, I should see a connection to port 80. On the Mac, This is my local address, a City College wireless address, 147, 144, 209, 388. This is my local port, which is this big number, because this is an ephemeral port. My end of a connection is used only while I'm viewing the page, and then it's gone. The server is up all the time, listening on a well-known port of 80. So all the people in the world can connect to that server on the same server port, but they'll each have a different local port, which is just a temporary port. So this combination is called a socket, and that's an established connection, which means I have done the SYN, the server sent me a SYN ACK, and I have sent the ACK. Now I have a connection, it's established, now I can send data and the server can send data, and it will be acknowledged and we'll be sure it got there. That's what's called a socket. This part is called an IP address. This part is called a port number. I have a local IP and port, and I have a remote IP and port, and those four numbers together create what's called a socket. So we can have two-way exchange of data as if I had my own cable going from me to that server. It's mixed with other people's data on the way, but sorted out at the end, so we can transmit data back and forth without it getting jumbled together with anybody else's data. When I don't use the web page for a while, it will start getting ready to close and enter the close wait status, and then it will eventually close. All right, so you can open connections and see them there, and we'll be playing with that. You'll be making a TCP handshake manually in Python later in this class, and getting used to seeing exactly what you have to do, which is important because this is the first step of taking over a server, is to do port scans to see what processes are open, and you have to understand how the handshake works to understand scanning. So let's take a look at that in Wireshark. Wireshark is also your best friend, runs on every platform. It is the best sniffer. Everybody uses it, even Microsoft people. Microsoft makes a competing product, but even Microsoft engineers use Wireshark, at least when their boss is not in the room. And so this Wireshark right now is sniffing in monitor mode, which is not interesting. We'll do that in chapter 11. Let me turn that off. That's here. Okay, and go back to Ethernet mode, which is the normal mode. Okay, now it's sniffing and showing me the packets. Here's UDP packets and TCP packets and so on. So I can filter. I'm going to filter for TCP.port equals 80, which is the normal HTTP port. And by the way, I could do the same thing with the shortcut HTTP. The web used to all be HTTP, now it's almost all HTTPS. So now I'm sniffing for HTTP, and there's no HTTP data going through my machine right now. But if I refresh this page, there will be, and there it is. Okay, so now I'm going to go back to show you the port, to show you the whole process here. Port equals 80, and enter. Okay, so let's go right to the start. I'm going to stop sniffing, because I don't need NOR packets, and look at these existing packets. So here is what happened. From my machine at 147, 144, I was talking to my server at 159, 203. The first thing I did was send a SYN packet from a local port of 59, 771 to a remote port of 80, because HTTP always runs on 80, except for occasional test services that run on a temporary port like 8080 or something. Normal websites run on 80. So I sent the server a SYN. At this time, 35.90 seconds. A couple of milliseconds later, at 35.913 seconds, the server replied with a SYN ACK. Then I sent an ACK, and that completed the handshake. Now we're ready to talk. So I asked it to show me a web page with an HTTP GET request. Get this web page and send it to me. The server sent me an ACK saying I received your request. Then it sent me the data, which came down here in these segments that are reassembled with an HTTP 200 OK and so on. Then my server went for the background image. When you load a web page, it loads pieces. First the HTTP, then the style sheets, then the JavaScript, then the images, then the videos, and so on. It sent a series of gets and got a series of responses from my server to build the web page. That's how it works. And we'll be delving into this in great detail, because this is how you establish initial connections to a server and find out what services it might have for you to attack. All right, so I got a few cahoots about that, and then it'll be time to take a break, and then we'll do a little more. I think we'll end up right on track here. So if you have some device that can access Kahoot, you can play this game. It's worth extra credit if you win. You can do it on a cell phone or a computer of any sort. There will be a URL showing up here soon to go to. This is 123, chapter 2A, which is going to be here. Okay. There. My Kahoot is loading. So go to kahoot.it and type in that number, and you can play this game. Which the reason I do this is just to keep people awake. I had a much less fun system that used hardware devices called iClickers, and then I went to Cyber Patriot, and I saw Kahoot, and I said, oh, this is great. The only problem is they don't charge any money, so I don't understand how they stay in business. But while they exist, let's use them. And hopefully they have some way to pay for this. People tell me there's a pro version where you can put your company logo on the quizzes and stuff. I don't know who would want that, but I hope a lot of people want it. They're giving them a pile of money. They're Italian, Kahoot.it. So, looks like people are still coming in. I'll wait another 10 seconds. All right, looks like, okay. Wait a few more seconds, people are coming. Chat, let's see. It should work remotely over the internet. Just a sec, good, okay, fine. Yeah, remote people can use it through Zoom with no disadvantage. They often do win. So Zoom is real time. The streaming through the college is delayed by like a minute, which because they go to television. And if you go on television, you have to delay it in case someone says a bad word. So, but this does not have any such filtering because it's not broadcasting to the whole world. Anyway, all right, another 10 seconds and I'm going. Okay, so 6 questions. Okay, what TCP IP layer uses IP addresses? Probably can make that higher. Yeah, I guess I can't make it much higher. All right, that's the internet layer, as you might imagine, that uses IP addresses. Those are the 4 layers of the TCP IP model. All right. What layer uses MAC addresses? It's the network layer in the TCP IP model, in the OSI model. But this is the TCP IP model. But it's also the network layer here. It's the internet layer. But this is, yeah, anyway, let me just review this because I'm seeing low scores and I think I didn't make a point of it. Let's go back to this slide. This is one clue for me. If people are doing that badly, we should go back. Here's the layers. The application layer uses real world addresses like www.yahoo.com that mean something to a human. The transport layer uses TCP and UDP port numbers, which are a number, 16-bit number that goes from 0 to 65,000. The internet layer uses IP addresses like 147, 144, 110 to find the physical location of a device. If you pick up your computer and go to a coffee house and connect, your IP address changes because your IP address tells it where you really are, like a zip code. And your network layer uses these MAC addresses, which are built into the hardware and normally never change. And let me just show you those. If I go here and do ifconfig, I see all my adapters, and my wireless adapter, which is the one I'm using right now, is here. This is my internet address, 147.144.209.88, and this is my Ethernet address, which is also called a physical address or a MAC address for media access control. It is 6 bytes, expressed as 2 hexadecimal digits, AC, BC, 32. Every network card has an address built into it, and they're all supposedly unique. And the first 3 bytes tell you the manufacturer. So mine are the Apple manufacturer. And the last 3 specify which particular device I have in that series. Anyway, that's a little Net Plus stuff, but I wanted to say a little more about it because I'm seeing too much randomness here. Although this one's closer. All right. So you send a SYN to a server that is listening. What's the reply? All right. Send a SYN, you get a SYNAC. All right. What happens on port 25? All right, that's SMTP, Simple Mail Transfer Protocol, how email moves around. All right, what protocol is on port 80? What's that? Yeah, you should pick one at the Kahoot. That's why these things are extra credit. I wouldn't use this for real quizzes because there are a variety of things that can happen. All right, and they're optional. I always have a few students that don't like the fast pace. You do not need to do this, but most people find it wakes them up. So where is Telnet? All right, it's 23. It's Telnet. Telnet is one of those things nobody should be using. So if you get a job at a company and they're using Telnet, one thing that you would be able to help them with is to tell them to knock off using Telnet. And it will be a test of your communication skills to see if you can express that in a way that will be accepted. So here's the winners that are going to get extra credit. Patrick and Bennis. And if those are fake names, or if they're common names, you might want to come tell me your last name. But let's take a break. It's 5 after. We'll pick up at 11:15 and do the rest of this chapter. So you get 10 minutes off. And if you're one of those winners, please tell me your last name so I can record it. And make sure you get your points. This is worth 3 points every time you win. I'm going to save it on my desktop.
My last name's Go.
Okay, which one are you?
Patrick.
Okay, Co?
Go. Gio.
Okay, good. Just a second. Let me save this. This K. Go. Okay. All right, sure. Patrick, go. Okay.
First of all, not one of the winners. Which of these is the lock picking one that you suggested?
Oh,
Because you said it was about $25, so I was saying.
it looks like they're all different than the one I got, but they might be better. I mean, the one I got was nothing super special. I can find it. Let me just take a look here.
There's also this one.
Just a sec. I think I've got Derek Eason. Okay. And
No,
Bennis.
it says privately and you have it on the screen.
Yeah, well, yeah, good. I've got, that's why there's some defects with privacy. And I know why I can't turn that off either. That doesn't broadcast though, but this does. Anyway, yes, I agree. That's a little bit clumsy. I don't have a solution. All right, I'm going to stop the Zoom. I'll start it again in 10 minutes. And now let me find that lockpick information for you. I believe